students. I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today I will be discussing compressive strength and flexural strength of concrete. So, this is a lecture number 4 of unit number 3. So, compressive strength is a very important, and generally tensile strength we neglect in the design, because concrete is very poor in taking the tensile strength, but it is having very good compressive strength. So, compressive strength, how to calculate the compressive strength of concrete. So, procedure has been given in Indian Standard 516 1959, reaffirmed in 2004. So, in construction, concrete is used only for compression, since its contribution is significant and tensile strength is negligible. So, due to the very low tensile strength. So, compressive strength is determined by loading molded concrete specimen, either it is a cube, a standard cube, or a standard cylinder in uniaxial compression until ultimate crushing failure occurs. So, these are the these are the different types of standard cubes. So, that size may be 100 mm by 100 mm by 100 mm, or 150 mm by 150 mm by 150 mm, or it may be 200 by 200 by 200, and cylinder is generally whatever the diameter is there, then generally height is double of that. But generally we have a customary of testing on cubes. While cubes are advantageous because of the fact that loading on the cast side can be avoided, because there is a two region. One region is we will get the plane surface, and other is orientation of aggregate. So, generally we have a procedure to test the cube. Suppose you have casted along this line, along this side, then we will be testing along this face or along the opposite face. So, that is the ease with which we can cast it and we can test it. But suppose you want to test it on cylinder. So, cylinder will be casting here on this edge. So, you will not be able to get the smooth surface. So, then capping is required. So, capping involves some tedious procedure. So, that is why we have a customary of testing on cubes. So, some of the country, like suppose you go to the USA, they have a customary of testing on cylinders. So, these are the standard size of the cubes. So, 150 by 150 by 150 mm, and it may have 100 by 100 by 100 mm. Suppose maximum size of aggregate is not more than 20 mm. If it is not more than 20 mm, then we can test on 100 mm by 100 mm. Otherwise, we have to test on 200 by 200 by 150 by 150 by 150 mm size. So, this one we can test up to 60 mm size, maximum size of coarse aggregate. But suppose you are using a more than 60 mm. So, in that case what we have to do? We have to go for larger size, like 200 by 200 by 200. Okay. So, generally suppose you want to test it, generally it is in the customary that it should not be more than 3 to 1 ratio. So, if aggregate size is if the aggregate size is, say, maximum aggregate size is 30 mm. So, we can have a testing 30 into 3. If you multiply, you can get how much? 900 90 mm. Okay. So, generally for this size we have to use 150 mm size, but if it is a larger one, then we can go for 200 by 200 and even more also, but there is a restrictions on the capacity of the machine. So, if the capacity of machine is limited, then it is better you go for the smaller size. Okay. Suppose we are using the very high strength of concrete, say more than 100 Newton per mm square. So, in that case, if our limitations of machine is there, say we have a capacity of only 2000 kilonewton, and that case will not be in a position of testing the cube, because that maximum load it will crosses. So, that case we have to reduce the size of the aggregate, and generally for high strength concrete maximum size of the aggregate is limited, generally around 12.5 mm and downside. So, this type of cube is also permissible, but normal field work our size is 150 by 150 by 150. About the cylinder, cylinder size is 150 mm diameter and height is 300 mm. And suppose you want to test if the size of the aggregate is not 20 mm, then in that case you can use 100 mm diameter and 200 mm height. So, this is the standard size has been given in the IS code. So, now I will discuss Platen effect. What is Platen effect? Platen effect means, suppose you want to test this, say we have a cube, and cube, say we have a size of the cube is, let us say 150 by 150 by 150. So, this one we are going to test under compression testing machine. So, let us say we have a machine head here, I will take the different pen here. I will take the different pen here. Okay. So, suppose this is the our platen here, this is a platen here. So, you know modulus of elasticity of this is a made of steel, and modulus of elasticity of steel is approximately 2 into 10 to power 5 Newton per mm square. What is modulus elasticity of concrete? So, modulus of elasticity of concrete depends on the grade of concrete, and generally it is much more lesser. So, for example, say empirically, suppose you want to know the modulus of elasticity, that is given by 5000 under root FCK. So, this is given in the Indian Standard Code IS 456 2000. So, this empirical formula has been given in IS 456 2000. So, say we have a grade of concrete, their maximum compressive strength is 25. So, in that case, say it is a 5000 under root 25. So, 5, so this will become 1.25 into 10 to power 4. So, almost you can say less than 10 times. So, what will happen if there is a friction between this surface and this surface? So, due to this friction, due to the friction, so there is a friction here. So, there will be composite action. So, say this is the Young's modulus of concrete and this is the Young's modulus of steel. So, concrete will try to expand, but due to the platen friction between the platen of the machine, this will not allow to expand. So, this portion will be under compressive action. So, in that case, what is going to happen? Whatever the cube you have here, a standard cube here, this is, I will draw the 3-dimensional figure. So, this is under triaxial compression, this near the surface, and this is a load is coming from the top. So, due to the triaxial compression, this is having the confining effect. So, say let us say we have a concrete, some concrete is here, that is a brittle in nature. Suppose we want to confine this, you have confined this concrete with due to the frictional action. So, this is going to take you more load. So, this is going to take the more load. So, due to this Platen effect, concrete is able to take at least about load about 1.2 times than actual strength, about 1.2 times 25 times more than actual strength. So, that here if the Platen effect is there, due to this here what we will get, we are getting a 45-degree angle here, 45-degree angle here, and result what it is causing, we are getting the more strength than whatever the actual strength is there. Okay. Suppose we by some means we remove this friction, either you can put the Teflon sheet in between. What we can put? Teflon sheet, which is considered at higher load also, it act like a friction, or suppose you put a good quality of grease in that. So, frictional effect will be less. So, in that case it is going to give you the actual strength, and failure pattern will be like this. Failure pattern will be, in this case it will be like this parallel, it will going to crack like this, and in this case it was going to, due to the, if you have a Platen effect, it is going to crack in this fashion because it is under confined condition. So, this is the going to give you the actual value, actual strength of concrete. But due to the ease in testing, we do this testing only, not the actual testing. Okay. But suppose you want to test on the cylinder, generally for if you want to do the want to get the compressive strength of concrete for research purpose, where you want a actual compressive strength. So, in that case what we do, we increase the height. So, if you increase the height, so diameter of this cylinder, say it is a d, so height is taken at least 2 times d minimum, it will be more means good. So, in this specimen it has been shown more. Okay. Here this is the diameter, this is the diameter. So, whatever this central portion is there, that may be having actual direct compressive strength. Here you will get actual compressive strength, here, and you will get a uniform stress throughout the central zone. We have a uniform stress, uniform axial compressive stress we will get. Okay. We will get the actual compressive stress. So, we know that according to Saint-Benen's principle. Okay. So, what will happen, suppose any load is acting here at this stage. So, here confinement effect is here near, and up to what distance? Up to d distance confinement effect will be there. So, d distance from top and from the bottom, and d distance from the top, and this central portion will not have confinement effect. So, due to that Saint-Benen's principle, we have this type of distribution of stress, means it is a informed stress. So, this is going to give you the actual stress. So, actual stress, suppose you want to get here for the cylinder. So, this is about, you can say, concrete cylinder strength, which is the actual one, is about cube strength divided by approximately 1.25. You may not get exactly, because this material is not homogeneous in nature, or it is not a isotropic material. So, you will always have a variation of around 10%, 15%, depends on the type of concrete. Okay. So, let us check some other thing. I have taken this graph from IS 456 2000. If you go to page number 69, you will get this graph. So, from there I have directly taken this graph. So, this is the stress strain curve. This is stress strain curve for concrete. Okay. So, here we are getting a parabolic curve here up to the strain of 0.002 and they have taken 0.003. So, this is the FCK characteristic strength, this is FCK characteristic strength. So, it is going to crack at this stress. So, how to get the strength? So, you have a cube here of the size, a standard size of the cube is 150 by 150 by 150 and the surface area will be 150 by 150. So, let us say this is going to crush, it is going to crush at say load P. So, compressive strength will be, what will be the compressive strength? Compressive strength will be given by crushing load divided by area of loading. Okay. So, area of loading is how much? 150 by 150 at P in Newton. So, say we are getting a 28-day characteristic strength FCK. So, in design what they have done, they have, this is having the test on cube, but suppose you want to do in design in a member. So, there they are designing in the flexure 0.67 FCK. So, what is there? They have multiplied this say 33% approximately they have reduced the strength. Okay. So, actual testing generally we can get around 25% higher result, but here they have taken 33%. So, for getting the actual considering the platen effect, the design they have reduced by 33% and the actual design we take 0.67 FCK. So, in this one we apply the partial safety factor in limit state method of design and working stress method of design we divide do by factor of safety. So, that is nothing but partial safety factor you apply for here gamma m 0.67 FCK by gamma m. So, depends on the here. So, limit state method generally it is taken 1.5. Okay. So, all these things will be learning in the next semester, not in this semester when you go for the design of the concrete structure. So, comprehensive study will be done regarding this in that particular stage. So, now I will discuss test for flexural strain of moldage flexure test specimen. So, that is going to give you the tensile strength. We are going to get the tensile strength. So, this is the indirect method of getting the tensile strength. Here we can see, observe here this member is going to crack in bending tension. So, there are two types of sample generally we use. So, what is the size of test specimen for flexure test is 50 mm by 50 mm by 500 mm. Another sample is you can use sorry not 50, it is 100 mm. We have to take 100 by 100 by 500, 5 times. Another sample is 150 by 150 is the cross section and 750 is the length. So, these three types of samples, these two types of sample we can do for the testing. One is 100 mm by 100 mm by 100 mm and another size is 150 mm by 150 mm cross section and length is 750 mm. and that will be subjected to bending, that will be subjected to bending. So, in bending, suppose we consider here, so this type of arrangement here, this figure has been directly taken from the IS 516. So, if you go to IS 516, all this test method for the strength has been given in that particular code book. So, you have to download all these codal provisions if you want to go in details. So, each and every procedure has been given in details here. Okay. So, rate of loading, type of machine, a specification for the mold. So, everything is given here, and that we will get in details in all these code books. Okay. So, if you see this table 2 of grade of concrete of IS 456. So, this concrete has been divided into 3 groups. So, one is ordinary concrete, then we have a standard concrete and high strength concrete. So, we have divided concrete types of concrete into 3 groups. So, in this one M stands for mix, M stands for mix, and this number, say I am taking this number 25. So, this 25 indicate characteristic strength, characteristic strength. Okay. So, details of characteristic strength will be discussed in unit number 4 when we go for the design of concrete mix. Okay. So, for briefly I will tell, characteristic strength will be established after testing at least 30 samples, and one samples consist of 3 specimens. So, around 100 samples, suppose you are 100 cubes you are testing, then you can establish what is the characteristic strength of particular grade of concrete. So, let us say we have this one M35. So, this is the compressive strength. What is this? Compressive strength. So, at the age of 28 days we have to test this. Okay. So, in 28 days one day you have to keep in air curing in mold and 27 days in water tank. Okay. And this is the values given characteristic strength here 10, 15, 20, like 25, 50 and 16 to 80. This is the old code, actually IS 456 2000, and if you see the amendment, so amendment has been taken in 2013. So, according to that, so this has been changed. So, this has gone M55 up to M60. M60 is the standard concrete, and then here they have increased this M85, M90, M95 and M100. So, they have changed this criteria. So, here what is the value M10 to M20 is ordinary concrete, M25 to M60 is a standard concrete, and M65, so M100 is a standard concrete, sorry, high strength concrete. So, we have divided this concrete into 3 groups. First is between M15, M10 to M20, and a standard concrete is from M25 to M60, and high strength concrete is M65 to M100. And suppose you want to find out flexural strength. So, based on the different tests, they have done flexural strength. So, they have given the empirical formula. Suppose you have a characteristic strength here. Okay. So, say I have a M25 graph, what will the approximately flexural strength? So, that you can find easily 0.7 under root 25, because 25 is characteristic strength. So, this is going to give you the direct tensile strength. So, this is your 0.7 and so this is nothing but 3.5 Newton per mm square, but actual strength we can get by testing only. So, if you see what is that relation between tensile strength, so you can find what is the percentage of tensile strength. Okay. So, in this case just you take 3.5 divided by 25 multiplied by 100. So, you will get around approximately, depends of the grade of concrete, these values ranges between 8 to 20%. Okay. So, if higher is the grade of concrete like M100, you can get a tensile strength of around 8 Newton per mm square. So, this is the indirect method of doing the test, and how to do the testing here. If you want to do this 2-point testing, so generally we have customary to do the test in this fashion. So, this was our test sample, here you have kept here, then here we are putting certain arrangement like this, arrangement loading like this. Okay. So, load you are going to put here, say this load is P. So, this will become P by 2, this will become P by 2. So, this is become P by 2, this will become P by 2. Say this distance is A and this span is L. So, if you draw the shear force diagram, so this will be the shear force diagram. If you want to draw the bending moment diagram, it will become the bending moment diagram like this. So, this value will be your P by 2. Okay. Say this is your A, B, C, D, A, B, C, D. So, this portion is accompanying shear force is 0. What about this part? This have a maximum bending moment. So, this will be nothing but say this will be nothing but P by 2 into A. Okay. So, this is this one. So, say this is the cross section of your say this is your cross section of beam. So, what is the moment of inertia? Suppose I want to find out moment of inertia about neutral axis. So, this is given by BDQ by 12, here B is equal to D. So, you can calculate the moment of inertia from here, and we know M by I equals F by Y equals E by R. So, consider this part, we will be in a condition of finding the flexural cracking strength of this beam FCR. Okay. So, this one you can calculate FCR with the help of this formula. You take M by I equal to F by Y. So, this is nothing but M by I by Y. So, this is going to give you the flexural strength of concrete. So, flexural strength of concrete, if you see this beam, if it is going to bend in this fashion, flex in this fashion, what is going to happen? This part will be under tension. So, this is under tensile force here, and this part will be under compression. So, as this will start going on cracking, and once one crack will develop, then it will crack with very high speed, almost speed of velocity of sound, and it will crack immediately, and the neutral axis going on shifting, and finally, this sample will get cracked. Okay. So, this is going to give you the direct tensile strength. So, this is very much important. So, today we have learned compressive strength. So, compressive strength is tested under a standard condition, and rate of loading is taken 140 kg per centimeter square per minute loading. Okay. So, like this we have understood. Thank you.